Okay, so we have this great utopia of services on the back end. We're going to talk about what could go wrong with all of this stuff, and that's what this is sort of the motivation for the exercises that you'll be doing for the next 3 weeks. So one of the issues in cloud security is, so this is just like the OWASP top 10 for the web vulnerabilities. You can take each one of those and say, does this apply to the cloud? And if so, how does it apply to the cloud? So I'll just be doing a brief rundown. Since we've already discussed this in the context of web security, I'm just going to go through an overview of how this stuff plays out in cloud resources. So the first one is broken access control. When we talk about access control, we have to talk about the principle of least privilege. The idea here is to only give users and applications the amount of permissions that they actually need to do the job, okay, and no more. And of course, this is not done very well in the cloud. So here's an example of an API that controls a car that was left unprotected so that someone could actually access the API and control the car itself, right? So they had to shut this app down because it wasn't authenticating access. So an adversary could actually control the car remotely. Here's another one. An upload API that was not protected. So the FCC had this thing up, and then people were uploading malware onto the site, and the malware would be like, I think this is what this refers to, having FCC issuing an apology to everyone for being so blind. Is the idea, is what happened there. Here's another one, authentication bypass. So the Instagram API leaked a picture of Justin Bieber's bare butt. On cloud resources, this happens. When we were talking about the other ones, those were just API, failing to protect APIs that were implemented in the cloud. Another part of access control is failing to protect the cloud resources themselves. So in this case, this happened in November of last year. You have the problem where you have over-provisioned users. So in this case, the employee of Twitter had too many sort of permissions associated with that user. So when you have a malicious insider, you have to make sure that that insider has restricted permissions so that they can't do a lot of damage. And this happens to any organization, especially like if you have to let go of someone in a company. You have to make sure that their permissions are not such that they're able to like implant a bunch of backdoors and then be able to get into that thing and wreck your business afterwards in retribution. And so Twitter had this problem where they had a site reliability engineer, and these are folks who just debug whenever things go down. Like figure out what the problem is, what resource went down, what machines need maintenance. So we had a site reliability engineer who ended up getting some responsibility accumulated over time and was able to eventually access user accounts and personal data. Now, there should never be a case where an SRE should have access to a user account. There shouldn't be. But this particular engineer was able to. And then developed a relationship with some Saudi intelligence agents and then started exfiltrating that data to them. So this is a problem of a malicious insider. And then when they did a post-mortem on this, this was what they talked about. Most organizations find it difficult to prioritize the work to stratify employee access. So this is the problem of access control in large organizations. Per person, you have to do a least privilege operation. And that's hard. That's hard to do. And that thing is changing all the time, right? So that's the issue. So the provisioning issue is one of the problems in the cloud. We also have the problem of over-provisioned servers. So you deploy software, and the software has way more permissions than it actually needs. And it's running on a server that you give excess permissions to. So this happened with the Capital One breach. There is a misconfigured web server component, and that thing, rather than just scanning network requests, was given access to all of the storage buckets on that project. And it didn't need access to all the storage buckets. So when that server got compromised and they got a shell on that thing, then all of a sudden that access turned into a full exploit on the S3 buckets that had all of the sensitive data. Okay. One of the worst labs from a security standpoint is this machine learning lab that I do in the cloud class, where they set, I think the credential is given out as either editor or owner for a simple app that does some image recognition. And so that is an example of over-provisioned access, where if anyone gets that credential, they can just completely wipe your project out, even though it was meant to just be a simple sort of image processing thing. Okay, so that was the exploit for Capital One. One of the problems with the Capital. So there's a lot of things wrong with the Capital One thing. We're just going to address these in pieces. Another thing that can happen in the cloud is exposing sensitive data. So the most common error is exposed storage buckets. So storage buckets that are left readable or writable. So in this case, all of these breaches, the RNC, the Verizon, and the Dow Jones leaks, they came into, the reason that these things were exposed was that the permission that was set on the S3 bucket said all authenticated users. So they're like, that must be secure. Like that setting screams to me security, but what all authenticated users means is that anybody with an AWS account that's authenticated can access these buckets. So this ended up, anybody with AWS was able to get the data, and that's how these breaches occurred. Okay? And these things were done, so all of that data was actually also unencrypted in clear text in these buckets. Okay? So this is the Republican, I think there are URLs here, happened in the RNC case. And then even the military has made a mistake of leaving a bunch of these images left open. Okay, another popular one is MageCart. So a lot of MageCart is a credit card processing system. And so one of the things that you would do is you would host your website that sort of implements your thing on a storage bucket. So S3 allows you to say, hey, I have a website. I'm going to upload it to a bucket. And then I'm going to point a URL to that bucket and then automatically serve that URL from the bucket. And then the bucket will handle replication and distribution. And so a lot of these sites are hosted on S3 buckets. And then some of these sites, this is a website, right? You want to make it open. It's intentionally open for people to access. But if you set it open and writable, then somebody can actually modify your website. And so when this happened, then a bunch of people, if you're running a site that handled credit card payments through MageCart, then what these adversaries were doing was changing your HTML so that it would go through them for the credit card processing. And then they were able to steal a whole bunch of credit card information that way by hijacking an S3 bucket. Okay. The problem is so prevalent, and this is something that you'll do in the last week of class, is that there's automated scanning to find all the open buckets that are out there. So you'll be running bucket stream, and it never fails. You run bucket stream, and then you let it run for 20 or so minutes, and you'll see a whole bunch of buckets that are just left wide open. Some of them are intentional with their websites, but a lot of them might not be. There's also this buck hacker interface that lets you automatically trawl AWS buckets. I don't have a lab for that, but we'll be doing the bucket stream one later on. So you like this interface? It's like, yeah, search for things that say payroll on them, and then see what buckets have objects that are listed with payroll, and then you can see exactly the stuff that's out there. Another issue is exposed disk backups. So we talked about virtual machines wanting to back up their disk volumes. So for EC2 instances, persistent disks are what they're referred to in Google Cloud. And they're often backed up for snapshots. So they're backed up into things that are called snapshots. And every company must take these snapshots, because otherwise you can get ransomwared, right? Like one of the key recommendations to address the ransomware attack is to make sure all of your backups work and the infrastructure works. So you're taking a lot of backups. The problem is if those backups have secrets in them, you have to protect them. And so there was a case in 2015 where one of the backups for I think this was Instagram, one of those was publicly readable, and that allowed the adversary to pull the AWS keys for Instagram out and then access Instagram as the administrator. That was in 2015. And this hacker tried to get the $1 million bug bounty from Instagram, and Instagram refused. So there's this history there. This exploit is one that you'll be doing in the flaws.cloud CTF, and that's why I bring it up. So you'll get to see exactly what the steps were to pull this thing off. And here is an example. They did a survey last year, or this particular study scanned the AWS cloud for any unencrypted open disk backups, and they found a whole bunch of them. So I think if you click on this thing, they found a whole bunch of disk backups that were publicly available that had source code, keys in them, emails and passwords. All of these things can be exposed in a disk backup. So hopefully when you point this tool at your cloud project, it won't show anything, is the idea. Exposed search instances. So we mentioned Elasticsearch. So if you have installed the Elk stack to monitor all of your infrastructure, but then you accidentally left it open, then that's the issue here. So on AWS has a hosted Elasticsearch service that you can basically use to index all of your content. Now, Elasticsearch is meant to be internal. You don't want, you want to be able to search your stuff, but you don't want other people to search your stuff. But the problem is if you actually expose the search interface publicly, then everybody can search your stuff. And that's what this is referring to. A mortgage company left their Elasticsearch instance open, and then the adversary not only compromised the Elasticsearch instance to find basically a whole bunch of links to documents that they wanted, but then also, on top of that, had storage buckets that were exposed. So not only was the Elasticsearch instance exposed, but all of the buckets that contained the documents that search instance referred to, those were also exposed. And so all of the data ended up being exfiltrated. So this was from last year, actually. Okay, so this is what you'll be doing in flaws.cloud. There's a level that shows you how to pivot from one to the next. Another real difficult thing is exposed keys. So we'll talk about service account keys and AWS access keys. These are basically the keys to the kingdom. And if you expose any of these keys, it's basically jailbreak on your cloud project. So Imperva basically had a data breach because a single API key was exposed, and that was enough to get into the AWS database backend service to get all the data out. Uber, they were breached in 2017 because they also had some credentials that were captured. OneLogin also had credentials. If you look, AWS keys that were breached as part of their thing. So that's a common pathway. The next one is exposed metadata, and we'll talk about the metadata service in a minute. The metadata service basically is a storehouse of all your authentication credentials for your virtual machines. So typically the access from your virtual machine, you want to be able to authorize your virtual machine to access some of your backend cloud resources. And the way that's done is it's mediated through this thing called a metadata server that's basically running next to your virtual machine. And so to get the authentication credentials out of there to send over to a cloud resource is what the service is doing. But if it's exposed, then that's basically what happens. That's basically one of the root causes of the Capital One breach. The metadata server was coughing up all of the access credentials for the VM that was running the web application firewall. I'm going to skip the cross-VM attacks. The next class is the lack of rate limits, and this is actually very topical. So when you don't rate limit access to your APIs, then you can do a denial of service attack on that API. Someone could launch one. You could basically do a resource usage attack. So if you want to cost your competitor a lot of money, then maybe you would hire someone to hit their APIs, and if the APIs aren't rate limited by the source, then you can charge a whole bunch of money to someone. The last one is brute force credential attacks on your cloud resources or on your application, and that was something that we referred to in the web application vulnerabilities. So the current example of this is the Twitter API. So Twitter, when you sign up for an account, you're usually binding a phone number to that, and you should never, for dissidents who want to be able to tweet things without having their identity known, you don't want it to be the case that the Twitter account can be associated with the phone number. And so the attack from December was that there was a flaw in the Android API that wasn't rate limiting the queries. And so a security researcher was able to match 17 million phone numbers to the actual Twitter handles using the fact that the thing wasn't rate limited. And almost immediately, and this happened, they mentioned this 2 weeks ago, Twitter finally found that there were a lot of people, there are nation states that actually leveraged the vulnerability to get all the accounts. So that's what happened in this case. Okay, the next set of vulnerabilities is insecure cloud configuration. So you will find that configuring a cloud project is really hard. There's a lot of things that make it really difficult. The first thing is that there's so much stuff in it. So there are, in AWS, there are more than 3,000 types of permissions and resources available for you to assign permissions to. Like on Unix, it's like, what, user, group, and other? But like, yeah, you're talking about a lot of different permissions, and most of these, people don't even know what some of these permissions do. You have another problem where you have users on the cloud, and we're talking about the users not as your application users, but these are the developers and the people in your organization. Those people have roles that are always changing throughout the lifetime of their career in your company, and you have to keep on changing their access, otherwise you'll end up like Twitter and have that person have access to data that they shouldn't. You have turnover, right? How do you handle people joining and leaving the company? Like, some of you are doing internships. Hopefully someone is provisioning you an account temporarily and then deleting that when you're no longer an intern. So is that process in place to make sure that the turnover is handled? When you are in a company, oftentimes you'll have collaborators, you'll have third-party integrations. So if you're using, like, for a CI/CD tool that's published by some third-party software company and you want to integrate it into your pipeline, you might need to allow access to that thing. So how do you configure the access for that tool on some of your cloud resources, but not give that tool too much access to do things like steal the data or exfiltrate the data? You have issues where you need to make sure certain data is sort of meets the sort of regulatory standards in this country and in Europe. So a lot of these privacy regulations, so FERPA, HIPAA, GDPR, you have to make sure you're compliant against all of those standards in terms of your ability to retain data and track data on users. If you are in a large enough company, you will find that you'll have a bunch of cloud providers to manage, right? Like, your software not only runs on AWS, but you have some of it that runs on Google Cloud, and then you're managing not only 3,000 on AWS, but you've probably got another 3,000 on Google Cloud, is the problem there. Okay, and then this results in intractably complex policies. And we'll just start on some of the security policies, some simple ones, but you can kind of see when we look at these security policies how they can turn into something really unmanageable. Okay, so I'm going to stop there for this. Yeah. So site reliability engineering you do need some of that stuff because you need a person to be able to diagnose why something crashed on your site, and sometimes it will need it won't be automated. Like if it's continually crashing, and Google's like, I'm just running what you're giving me, but if you have a bug in your code, then you might need something else. Yeah. Okay. So I'm gonna stop there. I wanted to get